Good morning, everyone. How are you doing? Is there? How are you doing? Oh, okay. It's kind of like church, I need to hear that response back. Okay. So, hello. I'm Johnny Green. I'm a director of the Energy and Transportation Science Division here at the laboratory, and we perform a lot of the energy efficiency research here related to buildings, manufacturing, and transportation. And so today's topic on climate change has a lot of interest to me as well because it intersects the world that I live in. This is a part of our Sustainable Campus Initiative seminar series. And so we, as you may know, we've got a Sustainable Campus Initiative that's been around since 2008, and it's our primary tool that we use to help us comply with the executive order that we have to meet certain energy efficiency goals and targets for the facilities here at the Oak Ridge National Laboratory. So the Sustainable Campus Initiative is a fantastic tool that we have to do that, and so there's a lot of different initiatives that they put forward to help us conserve water, save energy, and just help us to use our resources in a very responsible way. And so I have the pleasure of introducing Dr. Jack Fellows. So he's going to be, telling us all about how we're intersecting with Earth Day and climate change and how they all come together. And so he's had a fantastic career. And so he's the director of ORNL's Climate Change Institute. He has over 25 years of experience in leading large and medium-sized research and education organizations. He has a PhD in civil engineering and began his career as a research faculty member at the University of Maryland, where he conducted research using satellite data to improve hydrologic models. In 1984, he was selected as the American Geophysical Union's Congressional Science Fellow and spent a year working on science issues in Congress. And after his fellowship, he spent 13 years on the White House staff overseeing a broad range of research programs on behalf of Presidents Reagan, Bush, and Clinton, which is extremely impressive. And in 1977, he became vice president of the University Corporation for Atmospheric Research, or UCAR, which is a private, nonprofit weather and climate research university consortium located in Boulder, Colorado. And Jack has received several awards during his distinguished career. And without any further ado, please join me in welcoming Dr. Jack Fellows.
Thank you, Johnny. Is this on? Okay, great. Well, I really appreciate you all coming today. And it's interesting, as I look across the crowd, there's not too many people from the Climate Institute, which is actually good. There's some, because I think most of them have heard a lot of this before, so I'm glad to see a lot of new faces here. I got home last night at 2 o'clock in the morning, so I'm hoping I'm going to be coherent through all of this. But I want to talk a little bit about what we're celebrating today, Earth Day, a very special day of the year from my perspective. Then take a brisk walk through 500 million years of climate change. Then talk a little bit about what that means to us, that whole length of time, all the way from 500 million years ago to today. And then, if you can stay long enough, I'll tell you where to buy property in Hilton Head as sea level rises. Probably not for you, but maybe your children or your grandchildren. So before I get started talking about climate, I want to talk a little bit about Earth Day. I don't know that people know all the history of this. It started back in 1970. And that was really to rally international support for us being a better steward of this planet. And today it's celebrated by more than 193 countries. So this is a global event. And this is actually Earth Day Eve. Earth Day is usually the 22nd of April. But this year in particular is very special because in December, a climate agreement was adopted by 195 countries in Paris. It took us 20 years to get to this point, the adoption of this particular accord. And it's a treaty that actually is designed to try to keep global warming less than 2 degrees centigrade or 3.6 degrees Fahrenheit. So this is a real milestone in our global existence, that we're recognizing that climate change is real and that we need to do something about it. And we've chosen over the past couple of decades to make this marker at 2 degrees centigrade. Above that, we think that there could be very dangerous anthropogenic changes. Before I get into this, though, I also wanted to thank UT and the lab leadership for the shuttle that runs between the University of Tennessee and here. Particularly Teresa, I'd like to thank you for your leadership on that. It's been really nice. I've been a rider on this for most of the year. My crew is here in the audience. They actually sent me some questions beforehand that they were going to razz me. But if you haven't done this before, this shuttle runs from the campus. It stops at Pellissippi State Community College, where there's free parking, and then on to the lab. And one of the nice things about this is you get to go home at 4:45. Now, you may go home and work, but you're out of here, and you can do things afterwards. So this runs during the course of the normal school year at UT, but I know Teresa's working hard to see if we can get it to run over the summer as well. If you're interested, just Google UT Oak Ridge National Lab Shuttle, and you'll come up with the schedule and where it stops and everything else. But I highly recommend this on Earth Day, that we all try to minimize our CO2 production. So what are 2 topics that you try to avoid when you meet new people? There you go. Politics and religion. What's a safe topic when you meet new people? The weather. Okay. So I'm going to be ironic here. I'm going to talk about religion and politics. I'm going to start with that. Okay. So a lot of you probably know this Al Gore, to represent sort of the liberal left in terms of climate change. You may not know this gentleman. He's Jim Inhofe, and he's a senator from Oklahoma. He believes that climate change is the biggest hoax that's ever been presented to our society. Also of interest, a good friend of his is Bernie Sanders, socialist, and has actually said that Jim Inhofe is a really decent guy, but he has very strong principles. He's believes very deeply in a lot of different things. He's very religious, and he believes that it's arrogant that we could think that we could change God's climate. So he has principles too. So it's not, I don't, you don't really consider anybody a bad person, but that's the sort of the range that we're talking about, is from the very liberal perspectives of Al Gore all the way to Jim Inhofe. This shows up in comics too. So from the conservative perspective, this is just a comic that showed up that said Earth Week lectures on global warming are postponed due to heavy snowfall. Also in the liberal press, you get things like this: I'm with stupid, mankind. And when I think about this kind of conflict between people, it always reminds me of Mark Twain, who always said, the more I learn about people, the more I like my dog. So we have these conflicts here, these philosophical conflicts between the very right and the very left, and it actually sort of paralyzes our ability to talk much about climate change. But the viewpoints and the values are important. So people look at carbon dioxide, which is really the principal greenhouse gas that we're talking about here, as either an acceptable byproduct of good fortune and capitalism and what's really created our economy here in our country in particular. Other people look at it as a toxic byproduct of greed and consumerism. But the history is actually quite interesting. There's been very little human progress over a 4,000-year period, sort of prior to the use of fossil fuels. And it was really the Industrial Revolution that actually began centuries of unprecedented prosperity, and it was largely driven by fossil fuels, oil, gas, and coal. So that's actually generated a bunch of value questions. And that's what really sort of is at the crux of climate changes. And it's really whether all this prosperity has been uniform or managed well for all humanity. And also if, despite all the uncertainties that might be associated with climate change, should we err on the side of caution if this planetary scale CO2 experiment that we're running fails. This is the precautionary principle. And as I said before, sort of all the viewpoints here have kind of paralyzed our ability for almost 20 years to do anything about this until last December when we had this treaty in Paris. So we have some possibility here to lower our greenhouse emissions and also look for new economic opportunities. So I'm going to show you a couple quick graphs here. I don't mean to go into great detail, but I want to just show the relationship between various things. So I think I have to use this over here. So if you look at these charts here, so this purple line here is CO2. The red line is gross domestic product, so this is basically our economy. And then the green line is population, and blue line is life expectancy. This chart was actually put together by the Cato organization, a very right-wing organization, actually to argue that fossil fuels are good. And I think it's a valid point to say that for a long time, particularly if you look at the scale of life expectancy, we didn't live much beyond 30 years. And you can't say that life expectancy was all about fossil fuels. I mean, we had better health care and things like that, but there's a strong relationship between these. So you can see as we started to use fossil fuels, our economy grew, it allowed our population to expand, and we tended to live longer. And most of the fossil fuels that we used actually come from coal, oil, and natural gas. There is some biofuels and nuclear and hydro, but the bulk of what we've put into the atmosphere comes from fossil fuels, at least up to about 2005. I don't have a perfectly updated graph on that. And the thing that's really important is you think about, in 1950, we had 3 billion people on this planet. 2016, we're right around 7 billion. And we're going to have about 9 billion people in 2050. Now, I know there's a lot of various lines on this. But the thing that's important here, you can look at how China is sort of leveling off about 1 billion. India, still growing a little bit. Most of the developed countries are flat. The rest of Asia is growing quite a bit, and the developing countries are growing a lot. So if you look at the world population, the interesting thing in the message from this chart is if everybody in the world had a U.S. middle class lifestyle and energy use, we would have not been able to sustain that living 20 years ago. So we have to really manage this in the future. If these extra 2 billion people adopt the kind of lifestyle and the energy use that we have had, then we're going to run out of resources on this planet. So very important for us to be responsible about this. So it's also not even. The people that have contributed the most to greenhouse gases, and that's the red countries up here, are the people that have generated the greenhouse gases, but the people that are going to be impacted are the people that haven't. So this area down here. So there's a lot of social justice issues here. We've had the luxury of pumping all these greenhouse gases into the atmosphere for decades, while the other parts of the world haven't. We've been able to grow our economy. These countries in this region of the world would like to do the same, and we're going to have to do this together in some fashion so that we can have good, clean energy sources, but also strong economies. So we only have one planet, right? So we're going to have to take care of this very carefully. So when I think about that precautionary principle that we need to err on the side of caution here as we go forward, when I think about that, I think about this little girl, this little 3-year-old. This happens to be my daughter. And she's 27 now. And not that I'm going to be just a proud father here, but she's grown into a remarkable woman. She builds hospitals and schools in Africa. And for one of her vacations, she actually walked across Rwanda. And before she did that, she solicited letters of hope from people from our nation to express to Rwandans on the anniversary of the 10th year post-genocide that occurred in Rwanda. So she carried thousands of letters in a backpack across Rwanda, handing them randomly to Rwandans, saying how much we had hope for their country post-genocide. And works in the wine industry in California, so I've actually been working the last couple of months trying to figure out where the best climate change will be in Rwanda, because I suspect that she is going to move there at some point and adopt a bunch of little Rwandan kids. So I'm probably going to be a grandfather of a lot of Rwandan kids sometime in the near future. But this also reminds me of a Mark Twain quote that I think is really important for us to think about, that a clearer conscience is the sure sign of a bad memory. So we know that climate change is real now, and we'll have no excuse in the future to not address this. So before I get into the climate, I want to talk a little bit about the difference between weather and climate. I know everybody here from the Climate Institute knows this, but I've had a lot of people ask me when I do public lectures, how can you predict climate 100 years in the future when you can't really do a very good job next week on the weather? So there's real difference between weather. I see a lot of people shaking their heads, so you agree that we've got some limitations here. So there's a very big difference between weather prediction and forecasting and climate projections. So when you're talking about weather, you're really talking about daily variations of temperature and precipitation. And that actually requires you defining what the initial conditions of the atmosphere and ocean are at the time that you're going to do the forecast. And we're pretty accurate 3 to 5 days, but the errors grow over time because of those initial conditions that you've selected. And there's actually a theoretical limit to weather forecasting in about 2 weeks. So when you look at climate projections, that's a long-term statistical average of weather. And typically in the climate world, we think 30 years represents a reasonable trend. So that's the statistical period that we look at. And it's not dependent on initial conditions. You actually set what the atmosphere is going to look like in the future through some type of emission scenario or whatever. How much CO2 you're going to put into the atmosphere, what kind of industry, what kind of policies you have, and things like that. You don't have initial conditions. But climate models are actually reasonably good at reproducing the past history of climate. So it gives us some confidence about the future. And I hate to use death as an analogy. I search for all kinds of things, housing prices or whatever, but a good way to think about the difference, it's very difficult to predict when somebody might die. And so that's sort of like weather. But it's really easy to calculate the average American life expectancy, which is more like climate. So I give you an idea of how these compare. And by the way, this is meant to be informal, so if anybody has any questions, stop me along the way. So I mentioned to you that we're going to take a brisk 500-year walk through the climate. Explain this chart just kind of quickly for you. This is degrees Fahrenheit above a 30-year baseline from 1960 to 1990. So these are departures from that baseline. So this is 10 degrees above that baseline, 25 degrees above that baseline. Over here is the same thing in centigrade. And then these are the years from the present all the way to 500 years ago. So this goes 5,000, 10,000, 20,000, a million, 5 million, 100 million, 500 million. Okay? So this is the climate record over 500 years, largely from oxygen isotope measurements from seabed cores. So there's a lot of cycles in Earth. A lot of it has to do with our orbit. So during this period, we had about a 100 million year cycle due to the planet's orbit. And during this period, the planet looked essentially like this. Okay, so all the continents were jammed together. There was very different ocean circulation. There wasn't polar ice during this period. And what would typically happen is it could get colder, largely because of the way that the plates are moving around. And at some point, you actually then start glaciation. So the poles started to create here. As the ocean starts to cool, it can actually absorb more CO2. So it actually drives the temperature down even more. You're taking greenhouse gases out of the atmosphere. But at some point, it actually freezes, and then you can't put CO2 into the ocean, and then it starts being reabsorbed into the atmosphere, and you get these upticks in temperatures. Now, something happened very interesting. There's a lot of controversy around this, but right around 55 million years ago, it's speculated that an enormous amount of methane came out of the sediments and actually caused a lot of heating in the atmosphere. And then the continents had drifted into this configuration at this point in the Eocene, and the Isthmus of Panama closed right about this period, and we went into this long period of cooling, where in this period we had about 41,000 year orbit cycles, and then right around 1 million years, and there's still a lot of controversy of why this happened, it shifted to 100,000 year cycles because of the orbit. And then we went into this glacier period where we had lots of ice, and again, couldn't be absorbed into the ocean, so the CO2 and other greenhouse gases went into the atmosphere, and we started to warm up during this period. And then right around 10,000 years ago, we actually became very, very stable. And this is, in a sense, the planet has sort of reached some level of equilibrium. And what was incredibly important about that is we could have sustainable agriculture. So it really propelled our civilization forward during this period. I'm going to show the next slide that's going to blow up just this little region right here to show what's happening today. So you can see here that these are ice core from Vostok, where you can see this 100-year cycle that I was talking about before. So we were somewhere between 200 and 300 parts per million of CO2 for about 800,000 years. And then we got to basically the Industrial Revolution, and it has shot up in the last 100 years to 400 parts per million. And the thing that's important, I mean, you saw before, there's a lot of changes in climate over time. But what's really different in the last 100 years is the rate. So this temperature increase is 10 times faster than any time in the last 800,000 years. So that rate is critically important. And, oh, I'm sorry, let me mention one other thing about this. So if we do, so we're here right around 400 parts per million of CO2. If we have some policies to move more toward renewable resources, we can probably keep this around 600 parts per million. If we don't do anything, we're going to be up around 1,000. And nobody really knows what's going to happen if we reach 1,000 parts per million. And this ties into that Paris Accord of us trying to keep temperatures down. So I know you all have probably heard a lot about the greenhouse effect. This is not a new theory. It's from the 1800s. It essentially allows solar radiation comes at a certain wavelength into our planet. It's absorbed by the Earth. It changes wavelength. When it goes back out, it gets blocked by these greenhouse gases. That's a really good thing. If we didn't have this, it would be too cold to inhabit the Earth. So this greenhouse effect is quite real. We have continued to pump CO2 into the atmosphere since about the mid-1800s. You can see this seasonal cycle here. There's times during the year where the Earth is actually a sink of CO2 and then other times a source of CO2. That's just about the seasons, really. And then if you look at what contributes to climate change, you can look at this graph here. This black line here are actually the observations of the climate. And if you just use natural factors, whether that's orbits or solar cycles or volcanoes or anything like that, this is the kind of graph, this green is the kind of graph that you would get. And it's a broad line because this is the amount of error in these measurements. It's not until you actually add in the anthropogenic fossil fuel generation that you can actually match the observations. So I had said before that these models do a relatively good job of replicating past climates. So you can see that that's essentially true here. So again, we're right here about, we could be anywhere from, well, we're right here about 1 degree C, and we're trying through this Paris Accord to keep it below 2 degrees. So this is a really, really tough problem, and this is actually a slide that I stole from Jim Peck, matter of fact, although I've modified it a little bit. So the reason why this is a tough problem for us is we're trying to do a lot of different things across extraordinary scales. So we're trying to look at how carbon flows in and out of ecosystems and how we represent that in climate models effectively. We look at energy choices and how it impacts climate, how infrastructure is vulnerable to climate change, and how we can explore how to mitigate greenhouse gases, and if we can't do that fast enough, how we can actually adapt to changes due to climate change. But these are across enormous scales, second to centuries. So you look at sort of a depletion of a reservoir or the melting of a glacier, you've got to make a decision whether is that climate variability, is it natural variability, or is it actually climate change? And that's something that you have to look at, for 30 years to see whether you have a trend. We look at all the way out to a century, and then on a spatial scale, when we're looking at roots and how carbon flows through roots into trees, into the atmosphere, that's down to the micrometer, and then we're also looking all the way up to planetary scales, to hurricanes and things like that. So this is 12 orders of magnitude. This is a very, very difficult science problem. So I'm going to do a quick, shameless advertisement for the Climate Institute, though. The Oak Ridge, back in 2009, actually gathered a lot of the people that do climate research together and co-located them together in the Institute. You can see the vision here. This is the photo recently, a very enthusiastic group of people that work in the Climate Institute. And the kind of things that we do there, we've been involved in developing climate models for many, many years. And climate models have evolved since the 1970s, when we just had the sun, a little bit of greenhouse gas production and rain, all the way up today, where we've got atmospheric chemistry and ocean and land cover and things like that, very complicated models. And we've gone from resolutions of maybe 500 kilometers down to 25 kilometers, where you get a much better representation of topography and things like that. But the way these climate models work is we'll take the globe and we'll divide it up into these cells, and then many vertical layers also. And every time you double a model's resolution, if you go from 100 kilometers to 500 kilometers, you actually increase the computational need by a factor of 10. So just to give you an example, if you picked a model that was 100 kilometers, had 20 vertical layers, and you had 15-minute time steps, that means there's 2.5 million grid points in that sphere, and there's 27,000 calculations at all of those grid points. So that's why you have to have a supercomputer to run these models, and we typically will run these for 50 to 100 years, and it takes a month just to run a 50-year projection. So we run these things on supercomputers like Titan, which is the second fastest in the world right now. Right now we're at 27 petaflops, so that's a 27 with 15 zeros after it, calculations per second. In a few years, we'll have 150 to 300 petaflops, and in about 6 years, we'll have about 10,000 petaflops. So we're running models now at 30 to 20 kilometers. In this exascale era, we'll be able to run global models at 5 kilometers, which will be very important to be able to do that kind of modeling. So I'd mentioned this Climate Institute also tries to improve how we represent ecosystems in these climate models, particularly really sensitive ones. So I'm going to talk about two really quickly. One is called SPRUCE, and the other is the Next Generation Ecosystem Experiment in the Arctic. Both of these are looking at what elevated temperatures and CO2 will do to these ecosystems. So Spruce has 10 greenhouses right on the Canadian-Minnesota border. You can elevate temperature and CO2 levels in these, you could actually create the climate of 2100 in these greenhouses and see how these ecosystems react to that. The reason why that's important, this particular latitude around the northern hemisphere are peat bogs, and there's about 10 times more carbon in this ecosystem than a deciduous forest. So if all of that would come out quickly, it would dwarf what we put into the atmosphere to date as a civilization. We're doing somewhat similar experiments in the Arctic, looking at how CO2 and methane are coming out of the permafrost as it melts. So these are very important for us to understand these processes. Land cover is one of the elements of these climate models that is sort of least well captured right now. So we're doing a lot of work in that area, and we try to pull it all together. This is a water vapor model at about 27 kilometers, so it's showing features of things like typhoons, but it's overlaid on population. So we use all of this information that we're doing to actually look at how climate impacts agriculture, infrastructure, and so on. And it's particularly important to do this at a scale that people can actually understand and incorporate into their planning. And that's why, moving into that exascale region is really important, where we can run these models down at 5 kilometers and things like that. So you might think, who really cares about climate change? If I tell you that it's going to be 2 degrees warmer here, what does that mean to you? Well, it means a lot to a lot of people on Earth. This is in the Maldives. This is a collection of 1,000 islands just below the peninsula of India. And I had the great fortune of going here in 1998. The last organization that I ran was doing some aerosol measurements on these islands. And the president invited us to come and talk about climate change, because at 4 meters of sea level rise, this island will disappear and all of its inhabitants. This is a very interesting place. There's no room for an airport, so they actually leveled another local island, and you barely land on this island. Your plane jerks stopped right at the edge of the ocean, basically, and you climb into a boat and come across this little strait onto Mali. And when I came across, I came from Singapore. I was dressed in a nice suit and everything, got in this little boat, and there were 2 little kids in underwear bailing the boat the whole time we're going across this strait. It was basically a controlled sink, and I had my briefcase and my suit, and I was ready to swim at any minute. So it's, this is very real to a lot of people in the world, this climate change. And I will, again, talk about Hilton Head. It's at the end of this talk, because it will impact us as well. But just to bring it home to a little bit closer, just to give you an idea of where we are as the wonderful state of Tennessee, where we kind of stand on some of these issues. There's a great project that's sponsored by Yale University that actually does surveys on all the states on where its population stands on various questions related to global warming. So this is the percent of adults who think global warming is happening. So we're about 58%. There was about 4 million people that participated in this survey, so about half of them, a little over half of them, say that global warming is happening. It's interesting to look, though, that we only about 45% believe this is due to humans. So that's sort of the drop box, or the backdrop of kind of our culture. But if you think about Knoxville, I've only lived here for only 2 years. I almost said 20 years, but 2 years. But I found this a really lovely place to live, with incredible things like the Smokies and so on. So why should we care about this? So I didn't realize this, but we have 2 national parks here, which are the most visited in the country. And so both the Blue Ridge and the Great Smoky Mountain are really important parts of this economy here. So much so that both of those parks, the Blue Ridge Park brings in about the same amount of money. So about $2 billion of economy flows through this particular region due to those two parks, and about 25,000 jobs that are associated with this. So these are really, really important. I actually met with 35 mayors not long ago whose cities were, economies were tied to both of these parks, and they were, about 3/4 of them were skeptics to climate change. And when we started talking about this, they started to understand that they needed to pay attention to climate change because it will impact the parks. So just to give you an idea, I'm going to start at the regional level and then go at the local level. This slide actually comes from an important document called the National Climate Assessment, which was done in 2014. And it does sort of a regional look at climate change. So there's something really interesting about this area. For years, there wasn't much warming. It was relatively flat. And it was considered a warming hole. And it's essentially from Kentucky to Atlanta to Asheville to sort of Memphis. It has taken off since then. So we had a sort of brief hiatus, but it's starting to warm again. So there will be challenges in this area. There's going to be more days above 95 degrees as we approach 2100. When you put that much heat and moisture in the atmosphere, you're going to have a different kind of extreme event. So we may have fewer rainstorms, fewer ice storms, but they're probably going to be more intense. We should see 1 to 4 foot sea level rise, probably fewer but more intense hurricanes. And a lot of impact on tourism, particularly the parks. When I was talking to those mayors, there was actually a park ranger from the Smokies who was talking about species actually already moving in and out of the park, both animals as well as plants. So it's already starting to impact, and we haven't really seen big changes yet. Those are yet to come in the 2030, 2040 kind of time frame. But with all this comes some opportunities too. I mean, we're going to have fewer days below 32 degrees. So I think most people can probably relate to that being a good thing, except for the fact that if a lot of insects need colder weather to sort of minimize their population. So if we have fewer days below 32 degrees, we're probably going to have more insects and things that will spread. So that could be an issue. So at this regional look, at the National Climate Assessment look at this, it looks, reasonably well for the region. I was talking to the mayor of Knoxville not long ago, and I mentioned to this warming anomaly and just said, look, we have plenty of water here. We have a lot of electricity. We may have these hiatuses in warming. This could be a place where climate refugees from other parts of the country actually might want to come at some point in the future. So hang on to your houses, because this may be a very valuable place to be mid-century to late century. Now, the thing about if you drop down to the local level, so the climate assessment use climate resolutions, anywhere from about 25 to 50 kilometers. The Climate Institute here at Oak Ridge has actually looked at this at 1 to 4 kilometers. So really getting down to the point where urban planners can actually use this kind of information and put it into their planning. So, a different climate for Knoxville will have different extreme events, like I'd mentioned before. And so that will really impact how we move people around and how we keep people healthy. So if you look at this, the 5 counties that surround Knoxville, and just remember the Smoky Mountains down here, I'm going to show you 2 animations. One is for days above 95 degrees, and the other is for temperatures dropping below 65 degrees. So these start automatically. So they're going to run from 2011 to 2050, and they're relative to a 30-year earlier historical baseline. So you're going to see how many days are going to change over time in these colored animations. So here's the 95, above 95 degrees. This is below 65 degrees. So the number of days above 95 degrees. So you're going to see this turn purple. We're 2020 right now. We're going to head into 2050. And in particular, if you watch down here in the Smokies, you're going to have quite a few more days that don't fall below 65 degrees. So I'll let you, this 2035 right now, You really see this heating up where you have virtually 2 more weeks of daily temperatures above 95 degrees. And then here you have 30 to 40 more days that never fall below 65 degrees. And it's particularly important because in the Smokies, that's going to allow insects to survive over the winter and potentially devastate some parts of the foliage. And again, impact the economy. So I took a look at, I didn't have a lot of time to do this. I wanted to look both at July and December, but I only had enough time to look at the average July monthly midnight temperature. So what you will experience in the near term is not so much the hotter day, but higher lows. So it's not going to get as cold on certain days than it would in the past. So if you look at this graph, this is 66 degrees is the history of midnight in July for a monthly temperature for the baseline of 1966 to 2005. So that's what it had been for 30 years on average. At midnight in July, it's typically 66 degrees. So you can see over time, as we approach out to 2050, this is getting higher. So it's not going to be as cold. We're not going to have the lows that we typically have in July. I'm going to do this for December at some point when I get a time. I think you'll see substantial differences in December. So there will definitely be changes here in this region relative to the highs and lows that we're looking at. So enough of the bummer message here, but we really have to think about what we can do. And it's nice to have this Paris Agreement where we have all these countries that are looking at limiting the warming. What we're going to try to do is actually curtail the global emissions to the level that they can actually be absorbed naturally. So what we've done in the past 100 years is pumped such a faster rate of greenhouse gases that the natural system can't absorb that. But what we can do locally is things that can actually save you money in particular. So when you leave a room, don't leave the lights on. When you're going to the mall, don't go 4 times in a day. Plan more effectively to do that. Lower your thermostat in the winter, raise it in the summer. These are all pretty straightforward. Buy efficient appliances. You can push your local leaders to focus more on renewable energy, and you can buy locally. You can do all of those sort of things to help in this process. So we're not the only country that's going to do this. A lot of people, when you talked about the Paris Accord, you can't really, our emissions in this country are relatively flat, and you can't really have an accord like this unless you bring China and India, the fastest growing economies in the world. But China is actually moving very aggressively, as the way only China can do. They'll take an entire valley and flatten it and put photovoltaics all over the valley. And they are going to lead in this market. We have a lot of catching up to do here, and it's important as part of that Paris Accord for us to recognize that you can actually generate a lot of your economy by moving into green technologies. So I want to leave you with a couple of information resources. There's a wonderful website called skepticalscience.com, and it actually compiles what climate skeptics say about climate versus what the current scientific findings are. So it'll go down through all the kind of things that you've heard, that the climate has changed before, which is true, but it'll give you the science behind that, a lot like that 500 million years that we talked about, that it's just the sun, that it's not that bad, and so on. And you can get the science position on all these things. Another really interesting film, both of the Merchants of Doubt and Carbon Nation are on Netflix, and they're actually quite interesting movies. Merchant of Doubt actually chronicles the fossil fuels industry campaign to undermine climate science. And the interesting thing about it is the lobbyists that represented this were the exact same lobbyists that represented tobacco, pesticides, asbestos, and so on. And they take a very interesting position. They don't apologize for the misinformation that they do. They're trying to preserve our rights as Americans to make our own decisions. So they want you to be able to decide to have a cigarette, to decide to put pesticides and so on. So they take a very somewhat moral position, although I think if you misinform people, I don't know how moral exactly you are, but it's a really interesting movie. And then the Carbon Nation one has both complete skeptics of climate and very liberal supporters of climate change, but they're all entrepreneurs, and they're all really showing how they are actually saving money, regardless of what you believe about climate change, by moving into greener technologies. So I recommend both these movies as well as this website to you, and I promised to you that I would actually show you where to buy property in Hilton Head. So this is the time of this. So if you don't know, this is Hilton Head right here, and this is the really swanky part of Hilton Head. This is Sea Pines down in here. So I'm going to run a quick animation that actually shows what happens to Hilton Head as we move toward 2100. Somewhere between 4 and 5 feet is what is projected to be the sea level rise around 2100. So I'll start this, and you can see when you get between 4 or 5, you're going to start seeing particularly this end of Hilton Head basically disappearing. So again, for either your children or your grandchildren, you might want to say, this is a good place to buy property, this is a good place to put your summer rental contract. Even more so, this is a really nice place to think about property. So I'll just run this kind of quickly. And you can see we're at 2 feet right now, so you're starting to see things disappear. We're 3 feet now, 4 feet, and then, so 2100, this part of the island is essentially underwater. And then when you get, this will keep going to 10 feet. This would, hopefully, the Paris Accord will be effective and we'll never reach this, but at some point, a good part of Hilton Head just is completely gone. So I'm going to stop there, and I'd be happy to answer any questions you have, and happy Earth Day Eve, and have a wonderful Earth Day tomorrow.
So, give me what your thoughts are on the Captain Flag. What would you tell somebody who, I really don't know, if it was an effective tool, would it just be called trade or, but I would value it.
Yeah, well, other people should chime in on this too that might even be more familiar. To be honest with you, I'm not a big fan of cap and trade. There have been several that have been done both here in this country and in Europe. They've interested in a carbon tax. I know that's a difficult word to use, particularly in this state, but that is more associated with usage, and it puts a true social cost of carbon on carbon. So if you want to pollute, you need to pay for that. So that's sort of my general issue on that. But I don't know whether anybody else wants to comment on cap and trade, the pros and cons of that. Tony?
Just one point on some of the stuff I've read about it. The value of the cap and trade is the actual set the cap on what the emissions are. Carbon tax is generally most favored. If you're willing to pay for it, you don't have any cap. You continue to emit, you're willing to pay for it.
Yeah.
So that's the principle trade-off.
Yeah. Yeah.
So what is the comparison between moving things locally and moving things globally? For example, producing cars of vehicles, moving and producing cars of vehicles. So what is the carbon trade-off? Buying locally can be used to reduce the carbon.
Well, if I understand your question, I mean, try to minimize buying things where you know that there is, extreme transportation costs associated with that. But, that's a hard calculation to do, as an individual. So, it really gets down to the point of, if you're going to go to the grocery store, could you have gone to the farmer's market, locally and actually bought local produce? Or if you're presented with the option in a grocery store between transported vegetables and things like that to buying local, to try to buy local. Yeah.
Work. We can predict a year from now, here will be springtime, and 3 months from now will be summer.
Could you repeat that last part again? How well are the models compared? Oh. Yeah, okay, now I understand the question, yeah. So you're still going to have those same kind of, a spring and a summer. What will happen, particularly with summer's going to expand, The, yeah, so the sensitivity of the models to whether there's a springtime or not. I'm still not quite following your question here. Yeah, I'll give you, there's a lot of different answers to that, but I'll give you just one example. When I was talking to the city of Knoxville, particularly the water department, our very first conversation was, tell me if it's going to rain on this day in 2030. So there's no way you can do that. I can say that, in a particular month it might be rainy or drier or whatever. The sensitivity that you're talking about, particularly near term, is a tough one. It's, as you run these models out longer, we have more sensitivity in the longer term than the short term. So for me to say next spring, exactly what the spring is going to be, that's a bit of a challenge in terms of uncertainty. Would anybody else in the Climate Institute want to jump in on this? Okay. It's really been limited largely because of competition. When in talking to the city of Knoxville, 15 minutes was what most people planned for at the minimum. So I don't know that there is, but it would depend on the particular application that you were looking at.
So I appreciated your 500-year map of things like that. One of the things that I was thinking about is I know
Well, I think we are moving into that Gene, and to me, it's reflected in that Paris Accord. It took 20 years to get there, where people started to stop questioning this and started recognizing that it was pretty hard to refute the data that we had on this. So I think it already has started to change people's minds, not just in the science community, but I think in the general public. I mean, you have 195 countries agreeing to a tree. That's a pretty strong statement. Anything else? Yep. It's relatively short, yeah. So we're not trying too much. I mean, I think a lot of people are hoping that the continents are somewhat stable. We're not going to have those big changes that we saw in the last 500 million years. This wasn't a very pleasant, if you were at Earth Day 500 million years ago, it wasn't a pleasant place to be. So we're hoping the continents are relatively stable now and we won't go through those big swings, but we're still going to see interglacier well, in the past history, it's been more like 100,000 years kind of cycles, you know, in that sort of cycle. Yeah. Well, we'll see, right? I mean, this is where religion comes into this, I think, you know. It's hard to say, well, you know, what will. It's pretty hard to say what will happen. And, you know, like I said before, we have a responsibility, I think, for this time period to do what we can, you know, to try to maintain climate in some stable fashion. I saw one other hand here. Yep. Well, I don't think you can solve this without part of the portfolio being nuclear, but you know, it brings its own politics and things in the mix. So I think you're going to have to, you know, I showed that one chart that had all the fossil fuels, it had bio, I can't remember whether it had nuclear on there or not, it did, right? Yeah, so you know, you look at some countries that have gone all in on nuclear and then are starting to pull back a little bit. So, but again, I don't think that you can solve this problem without looking at the full suite of possible energy sources. So it has to be part of the mix, but I know there are people that are actually exploring things like paintable voltaics. So think about everybody being able to paint their house with solar collecting paint. I mean, the one way you could solve this problem is through photons. There's lots of photons hitting the Earth, and if we could capture that more effectively and not through really expensive silicone and stuff like that, that could be a solution. But in the interim, I don't think we can address this without including nuclear in the issues. Solve all the residual issues like waste and things like that.